Hello everyone, welcome back to Data Science Monster. Today we are going to make support vector machine, which is SVM, super easy to understand. Whether you are just starting out with machine learning or looking to refresh your knowledge, I will walk you through SVM using simple examples and with a clear explanation. So what is SVM? Imagine you have two types of fruits like apples and oranges, and you want to draw a line on a paper to separate them. So SVM is an algorithm that does this for you, finding the best possible line to divide it. So it can also do this in more complex scenarios, because why I come up with this, why do I say that it can be able to solve complex scenarios? Because the same thing we have discussed with the linear and logistic. So you may be wondering, like, if linear and logistic is able to do such task, why SVM, right? But when the data is being really complex, right? A linear regression or logistic regression may fail in that case. If it is regression, linear regression may fail. If it is classification, logistic regression may fail, right? So even though it is a complex scenario, definitely SVM will be helpful to do it, support vector machine, right? So in short, what I can say, in linear, we have discussed about the straight line. In logistic regression, we have discussed about the sigmoid curve. In support vector machine, it is about the hyperplane, right? You can see that it is about the hyperplane. So how does SVM work? SVM's job is to find out the best fit line, or I can say boundary, that basically separates the two different groups of data. But it will not stop over there. Instead of that, it would be looking for the line that is giving more space between itself and the nearest data points. Right? I will explain that. So you can see that what is hyperplane? Hyperplane is a decision boundary that differentiates the two classes in SVM. Right? Then the next one you can see like support vectors. What are support vectors, right? So that's the next question. So now if you look into this, assume that there are two classes, red color as well as green color data points, okay? So I just want to make the classification. So with just a line, I'm trying to make it into two different classes, right? So now if you see that this red point is close to this line, this green point is close to this line, right? Likewise, if you see, this is also looking close, right? So the points which are closest to the hyperplane, right, are called as support vectors. So if you come back here, what is hyperplane? In the real world, generally, we won't work only with the two dimensions. Sometimes we have many features. When that happens, the boundary SVM will find a hyperplane. It is basically, if we have two dimensions, we call it like a line. If we have more than two dimensions, then we call it like a hyperplane. So what are support vectors? All the data points are not equally important in support vector machine. The most important ones are support vectors, which are nothing but the points which are closer to the hyperplane, right? And now there would be the next question, right? So what is that question? If you look into this one, I can draw a line here, right? Here I can draw a line and separate these two classes. I hope all of you agree with me. I can draw a line here and I can separate these two classes. So I can draw here, I can draw here, I can draw here, right? So you can see multiple lines here, which is being considered as the best fit hyperplane. So if I ask you this question, you may be definitely telling me like, yes, BCA would be better because there is no misclassification. Because if you go ahead with this D, you can see that in this region, you could see one misclassification. In case if you go ahead with this also, like we can see some misclassification, right? So definitely we would be thinking that B would be better, C would be better, A would be better, right? So now, why this is better, we thought because D and E, we could see the misclassification, right? So we are freezing with this. Then there is the next question. You can see that this point, right, which is closed here, here this is closed. This we called like support vectors, right? So now, in this particular case, what we need to understand, whether I need to consider line B or C or A. It is advisable to go ahead with the C because B, if you see, it is close to this point. Likewise, A is close to this point, right? Also, I can draw another hyperplane. What is the another hyperplane? Can I draw here like this? Like this also I can draw a hyperplane without any misclassification. But is that a good hyperplane if you ask me, right? Is that a good hyperplane if you ask me? Definitely, right? Definitely I will tell you that that's not a great idea. So what I'm talking about here, this one, right? This is not a good line. Why do I say that it is not a good line? Right? The reason is the space, the distance between the two vectors is been very less. That we call it like a margin, right? So always we want SVM model to come with the highest margin. So SVM does not just draw any boundary. What it does is it will try to make sure that the gap between the support vectors, the gap between the data points where we are drawing the hyperplane is great or wide as far as possible. This gap is called the margin. So if the apples are on one side and oranges are on the other, SVM will find the line that gives the most room without getting too close to both the group. Right? Perfect. Right? So that's why not line A, not line B, line C is better. This is what we could see. Right? So now if you look into this one, right? If you look into this one, can I go ahead with linear or logistic? May not be a great idea, right? You can see that one class is over here and the other class over here. How can I go ahead with this, right? So a simple straight line cannot divide this, right? This is not looking like linearly separable. So what I need to do, I can go ahead with the kernel trick. So the kernel trick is like giving SVM a superpower. What it does, it takes the complicated data which cannot be separated and it will transform it into higher dimensional space. Very simple. Just imagine this. You just add a dimension over here, which is pulled towards you, z-axis, right? X and y-axis we have. Z-axis would be towards you. So when you extend this towards your end, you can see something like the red would be in one circle and the blue would be like another circle, right? The red would be in one circle and the blue would be another circle. This is basically called as kernel trick, right? So why support vector machine could handle the complex cases also? Because of this kernel trick, right? So there are different kernels also. We are going to discuss about it. But if you check in real life, data is not perfect. Some apples might sneak over to the orange side, and that's okay, right? So SVM allows a bit of flexibility with something called like a soft margin, which means that few points on the wrong side of the boundary. Hard margin means this would force a strict separation, but in messy data, a soft margin works better, right? So now let us look into the kernels. One kernel is linear kernel. You can see that the boundary is basically a straight line. So most of the data set is not linearly separable. So in such cases, linear kernel may not be helpful. Or when it is like this, as I told you, you can add one more dimension which means you can pull it towards your end. So red would be in one part and the green would be on another part. So now we can separate it with a hyperplane, which is called as Gaussian or RBF kernel. Whenever we write this SVM algorithm, the default kernel would be RBF kernel. The next one is like a polynomial. Sometimes when the data is not uniform, there you can go ahead with this poly. But when there is a problem with the polynomial kernel, if the number of dimension features increases exponentially, right? The problem with the polynomial kernel is the number of dimension features increases exponentially. So might be this could take, no, this could be more expensive than RBF or linear kernel. According to me, even RBF is expensive, right? Okay. So now we may be thinking like, okay, we could see kernel trick, which is really helpful for us. But we should also understand what are the advantages and disadvantages of SVM, right? So SVM is great whenever we have data with many features or dimensions. It does not use much memory also, so it is efficient, but it is not best when you have a huge data set or when there is lot of overlapping in the data groups. It is powerful, and I have seen many situations it was performing really too good, right? So there is no doubt about it. But as I told you, support vector machine may take more time to run, and that has been the biggest challenge with the SVM. But SVM can work well with the unstructured data also. Hope all of you got the concept of SVM now. Hit like, comment, and do subscribe the channel. Thank you.